Okay, so this is an honors geometry assignment only. Section 12.4 talks about angle measures and segment lengths. All this is related to circles, okay? All right, so we're going to talk about angles first. So we already know central angles are equal to the arc. We know inscribed angles are equal to half the arc. So now, what about an angle formed by two lines that intersect in the circle? Well, what we have here is we have two chords. So from here to here is one chord. From here to here is another chord. It creates four angles. We're going to focus on angle one, this angle right here. Notice that angle one opens up to X, this arc, and then its vertical angle opens up to Y, that arc. This theorem says that the measure of an angle created inside of a circle by two intersecting lines is going to be equal to half the sum of the arcs, the one that it intercepts and the one that its vertical angle intercepts. Okay, it's just what it is. Now, again, this is not the center, not the center. All right, so again, there is no center in this picture. All right, now, the reason I have this definition down here is because what they have shown here is they've extended these chords beyond the circle. And when you take a chord and you extend it beyond the circle, you get what's called a secant. A secant is a line that intersects the circle at 2 points. So you can see line AB is a secant because it goes beyond the circle. Now, if I put points C and D right there, that would be chord CD. And again, as it says, a chord is part of a secant. So secant is a new word for you. And again, if you remember from your trig, your extended ratios, the reciprocal ones, secant was one of those. It was actually the reciprocal of the cosine. But again, I'm not sure what the relationship is between this physical secant in geometry and those trig ratios. So now we can use secants and tangents to build angles outside of the circle. So here in this picture, we have two secants. In this picture, we have a secant and a tangent. So we have a secant and a tangent. And in this picture, we have two tangents. But nonetheless, the angle, the vertex of the angle is outside of the circle. So when the angle is outside of the circle, you're going to subtract the two arcs that it intercepts. It's going to intercept two arcs, one closer, one farther. Typically, we take the farther minus the closer. So when you do this subtraction, and it's half of that, the X, the first one, is the farther arc, and Y is the closer arc. And again, it's just because as you get further away from the angle, you have a bigger arc out there because your sides get wider, okay? Now, this situation, the two secants, is very interesting because there is a relationship between X and Y. Together, X and Y make the entire circle. Because of these two tangent points, there's only two arcs that make the circle. So in this case, X and Y is 360. So that might be helpful when you do a problem like this later on. So be aware of that. Okay. All right, cool. So those are the angles. Now, these angle problems are actually not in Delta Math, so they're in Edulastic. So be aware of that. Okay, so now we have some segment problems. So again, we can use chords, secants, and tangents to do some problems. So this first example here is our two chords problem. So when it comes to two chords, you simply just multiply its pieces together. So A and B make up one chord, multiply them. C and D make up another chord, multiply by them. That is how you'll find one of those lengths. Okay. And again, notice the center is here. It's not on there. So the center doesn't matter. Okay. This is the two secants case. When you think of secants, I invite you to think of whole times part. So when you look at this top blue secant, W plus X, that's the whole secant. And then W is the part. You're going to multiply them. Now it's the outer part, right? So be aware of that. It's not the inner part. Same thing here. Y plus Z is the whole secant times Y, which is the part. And again, it's the outer part. So be aware of that. And then over here, you have your secant tangent example. So for the secant, you handle it the same way, whole times part, But for the tangent, you simply square the tangent segment. Okay. So again, don't try to memorize these. Write them down. Use the pictures, and then you can apply them to your problems. Again, Delta Math does have problems involving these, so you will do them there. I'm going to put a couple trickier ones in Edge Elastic that incorporate multiple situations, and we'll do some examples today as well. Okay, so this video is attached to Delta Math, where I'm going to do some basic problems involving these segments, and then you'll go to Edge Elastic, where there's a video in regards to some angle problems and some more complicated segment problems. All right, very good.